Hello students, this is one more important question from the chapter straight lines, which is important for 5 marks in the board examinations of Karnataka in first PUC. So that is equation of the line in normal form. The question was like derive the equation of a line in normal form. So first thing is you need to write a diagram and explain the diagram. So before that I want you to tell some background about this. Suppose a non-vertical line is known with the data of these 2 points. First thing is you know the length of the perpendicular from the origin to the line. Second point is angle which the normal makes with the positive direction of the x-axis. If you know these two things, then you can derive the equation of the normal form of the equation of line. There will be 4 possible lines. Okay, so that is already shown for you in the textbook. Now I will show you here. These are the 4 possible ways we can draw a line. Okay, the purpose is to find the slope of the line L and a point on it. Okay, now we'll derive this one. So for examination you need not write all these 4 diagrams, you can take down any one of this. Okay, now first thing, so let L be the line. Okay, so first we shall draw one diagram, then we can explain this statement. Okay, so there is x-axis and y-axis. So draw x-axis and y-axis and a line L, either an increasing line or decreasing line. Now I am taking this line in the first quadrant, which I have shown you out of 4. I am taking the first case. Let this line be L, whose perpendicular distance from the origin O, that is O. Okay, this is a perpendicular distance from origin to the line. Okay, that is OA. I'll call this point as A and this distance as P. So let L be the line whose perpendicular distance from the origin OB, OA equal to P. And the angle between the positive direction of x-axis, that is this one, and OA, this OA, is XOA is equal to omega. So from origin I have drawn this line. Now this angle is omega. Okay, now the possible positions of the lines in the Cartesian plane are shown. So I shown you before, this is one of the position and this is the first position. Now our purpose is to find the slope of this line L and a point, that is A, on it. So we'll draw a perpendicular AM. So that is on the x-axis. From x-axis we draw a perpendicular to point A. So this is 90 degrees. I know this is also 90 degrees. In such case this is also 90 degrees. Now to find this point A, and I call this as point M. So you know I'll take sin theta and cos theta. So sin omega in this case is opposite by hypotenuse. Opposite is AM and hypotenuse is P. And cos omega will be is equal to adjacent by hypotenuse, that is OM divided by P. Now I have AM is equal to P sin omega and OM is equal to P cos omega. So by this what I mean to tell is, this point A is distance from x-axis, that is OM. So that is given by P cos omega, and its distance from y-axis, this point, is equal to AM. That AM is P sin omega. So I got a point A. Now I need to find the slope of point L. Now we know the slope of the normal. Okay, now I need to find two things, that is the slope of the point L and a point on it. So I got the point A. Now I need to find the slope. Therefore, from this I got that the coordinates, see from this diagram I found out the coordinates of point A as P cos omega, comma P sin omega. Now I need to find the slope, that is slope of line L is equal to minus 1 by slope of normal, because if two lines are perpendicular, then we have the formula, that is m1 equal to minus 1 by m2 or m1 m2 equal to minus 1. So I am using the first case here. Now slope of the normal we can find easily, because we know the inclination with the positive direction of x-axis as omega. Therefore this slope m is equal to minus 1 by tan omega. That is minus 1 by tan omega, which is equal to minus of cos omega by sin omega, because tan is sin by cos, because it is minus 1 by tan, so it should be minus cos omega by sin omega. Now this is nothing but slope. Now we know equation of a line in slope intercept form. See, that is we know slope and one of the intercept form, or a slope and a point form, or we can say slope point form. Because we know the point A and also the slope. We got the slope and we also got the point. Now that is y minus y1 is equal to m into x minus x1. Now this is our x1, y1. Therefore when you substitute this one, we get y minus p sin omega is equal to minus of cos omega divided by sin omega into x minus p cos omega. Now I will multiply this sin omega to the left, so I will get y sin omega minus p sin square omega, which is equal to minus x cos omega plus, because minus into minus plus, p cos square omega. So what I can do now is, this squares I will try to bring one side. So if I am doing this minus left side, I will get x cos omega plus y sin omega is equal to, if I take p common here, it is cos square x, this minus p sin comes this side becomes plus, p are taken common, so sin square x. Sin square x plus cos square x is 1, therefore it is p into 1, which is equal to p. Therefore we have the derivation here, that is x cos omega plus y sin omega equal to p. Hence the equation of a line in normal form. So it's very easy, children. See, first thing is we have 4 cases to derive the equation of a straight line in normal form, equation of line in normal form. So first we should know 2 things, that is a point on the line and angle made by the normal in the positive direction of x-axis. Okay, if you know these things, then we will consider let L be the line. First learn diagram. You can write any one of the diagrams in the 4 cases. Let L be the line. See, this line I am taking here as line L. Let L be the line whose distance perpendicular from the origin O is P. That is OA is equal to P. That A is the point on the line which is perpendicular to the line L. That OA, when it's extended to origin, it is perpendicular to the line L. Then draw a perpendicular from x-axis to meet at A, that is AM. Let omega be the angle in the positive direction of x-axis, which is the normal makes. That is, let the normal makes an angle omega in the positive direction of x-axis. Now we shall find the coordinates of a point on the line L and the slope of the line L. First thing, see, this OMP is a right angle triangle. Therefore, sin omega is equal to AM by B and cos omega is equal to OM by P. Therefore, that is opposite by adjacent, opposite by hypotenuse and adjacent by hypotenuse. Therefore, AM is P sin omega, OM is equal to P cos omega. Therefore, the coordinates of point A are nothing but OM, EAM, that is distance from origin to the direction of x-axis and y-axis. So it is coordinates of here P cos omega and P sin omega. Now the slope of the line L is minus 1 by slope of its normal. Slope of the normal is given by tan of the angle inclined in the positive direction of x-axis, that is minus 1 by tan omega, that is equal to minus of cos omega by sin omega. Now we know the slope of the line and also a point on the line. Therefore, by point slope form, y minus y1 is equal to m into x minus x1, we substitute it. Then we cross multiply this sin omega to left and minus cos omega to the bracket. We get this one. Then for that we simplify by sending these squares on one side and the remainings to the other side. So cos square plus sin square becomes 1. So we arrive at the normal form of the equation of the line, that is x cos omega plus y sin omega is equal to P. This is one of the important question, okay, for 5 marks in the board examination. So I told you there are 3 questions which may be important for you for 5 marks in this chapter. It is in the textbook, okay, it is in page number 217. Okay, angle between 2 lines I have given in the last video. Now this is the next important derivation for the 5 marks questions. Okay, you can repeat it and learn, and then you learn it to write without seeing. You will get a very good marks and very easy to learn, and you may get a 2 marks question on this, if not a 5 marks question. Thank you.